Good morning. So thanks for coming to this talk today. So before I start, perhaps I should introduce myself to you. I'm Dr. Ernest Wong. I realized that I have two types of audience today. One is online and one is physically present here, who is now sitting in front of me. So nice to meet you all here. So I know that I was supposed to talk about biomedical science, the so-called biomedical science today. So that has something to do with life. So perhaps I should show you this picture. And I think all of you should recognize that this is the picture of a tree. And indeed, in ancient times, people thought about life in terms of a tree. And when I look at the relevant literature, I think there are reasons for our ancient ancestors to try to understand life in terms of a tree, because what they said is that life, first of all, does not exist on its own, right? So it's not an isolated phenomenon, and it is actually connected to every other things in the world or in the universe. And then life, according to our ancient ancestors, is supported by the Mother Earth, right, for materials, for substances that will be responsible for building up life. And also, life is dependent on the sky for energy. So looking back, it's not unreasonable, right? So, of course, thousands of years ago, right, our ancient ancestors still did not know about there's a thing called photosynthesis, right? They don't know the function of leaves, right? But yet they are able to say that, well, as far as a tree is concerned, the tree gets the energy for growth from the sky. So that's the early perception of life, right? The perception of our early ancient ancestors. And at around the same time, that's their understanding of life. And again, all right, we need to go back to the ancient literature to understand one endeavor of our ancient ancestor, and that is their urge or their hope, right? The very fervent hope for being able to live forever. So, and that actually is the beginning of biomedical science. Although at that time, of course, we didn't have that term, biomedical science. But then it is the endeavor to live forever that sets the beginning of biomedical science. Were they reasonable to have that sort of endeavor? I think, right, again, there are reasons to understand why our ancient ancestors would like to live forever, or why they think that it is reasonable to expect that life is eternal, that life is forever. Well, first of all, it is because, right, if you could still remember, right, the interpretation of life as a tree, then, and because life is part of the nature, right, or our universe. And of course, at that time, it is logical for them to think that nature will last forever. And because life is part of nature, and therefore it is logical for our ancient ancestors to think that they could, or life should be forever. So I'm not sure whether you have seen this sort of pictures before, right? This is a picture of the East, and this is a picture of the West, right? But there are some commonalities between the two pictures in that you may discover that they are trying to make something, right? So what do you think that they are trying to make? And maybe you can get some hints from the Chinese there. All right. So they are trying to make what we call a type of substance known as the elixir. The elixir is a type of medicine that if somebody drank it, then that person could live forever. Elixir. But do you think that they have succeeded in making an elixir? Of course not, right? Otherwise, right, all these people will remain alive today. The fact that they didn't means that they must have failed in making that concoctions or medicine known as elixir. But failure is one thing. Perhaps we should start to think about why. Why did they fail, right? Because they have good reason to believe that life could be forever. And then they must be doing this according to some sorts of principles at that time, that, right, a formula for them to make the so-called elixir, yet they fail. So we must think about why. Why did they fail? Right? Yeah, so now this is the next slide. So although our ancient ancestors have failed to make the medicine so-called elixir, it doesn't mean that they have given up their hope. They didn't. And the hope actually still persists at this moment in time. The answer is no, right? The hope to live forever has never been given up, right, by humans. We're still hoping to the same thing today. But then I think we have trying to disguise our hope, right? So instead of asking whether we can live forever, still there are people asking how long can we live, right? I think this is the question that remains in the mind of every one of us. How long can we live, right? And then we can also rephrase the same question. That is, how long are we designed to live, right? How long are we designed to live? And or we could starting to become a little bit more realistic or scientific and to ask again, can we be freed from diseases, right? So I think that's the more realistic question now, right? Can we be free from diseases? And then we have some better terms, longevity. Longevity. If you Google this word, right, a lot of articles will pop up about longevity and healthy aging. Healthy aging. Meaning that, well, perhaps we cannot resist, we cannot avoid aging, but we can perhaps look for one thing, and that's how that we can age healthily, right? Living healthily, right? Although we will continue to age. I think, so these are the sort of questions that we are now asking, instead of the same old question that was asked by our ancient ancestors, eternity, can we live forever? So the focus has changed, but ultimately, think about this. If we could achieve longevity, if we could free from diseases, right? Finally, of course, the next question for us will be, can we really go back to the same question and to live forever, right? So that is a natural sort of a human way of thinking. Right, if we sort of cannot, right, put that old question aside, if we are still actually pursuing that question, although, right, we have that question being asked in various ways now. So if we still want to do that, we really need to think about it seriously. Why couldn't our ancestor find the answer to their question? Why? At least, right? Why couldn't they develop the real, true elixir? What is the question? Right, the question, of course, how to live forever and healthily. So without any disguise, all right? That could still be our ultimate aim. So why? You mustn't ask ourselves, why do we fail in order to succeed? So let's reflect on some of our daily experience. Supposing that we have a bicycle, we have a motor vehicle, anything else, a broken tap, a broken camera, a broken clock or watch, or when we try to repaint a wall in our house or in our apartment. What is our experience of that, right? First of all, if we have a broken bicycle, we have a broken motor vehicle, the first question that may come up to your mind or to our mind will be, can we repair them? Can we repair it, right? Are we able to do that? Well, of course, the answer will be yes or no. Yes, we can, or no, we can't, right? But then, in case the answer is no, we can't, have we ever thought about the next question? Why is it that we are unable to do the repair, right? What is missing, right? What is missing? Why are we able to do that? Well, why aren't we able to do that? Is it because we don't have the manual, right? Is it because we don't have the instructions? These days, when we buy a washing machine, right, you will find that in the manual, there is a specific section telling us how to solve some of the common problems, right? Actually, how to replace some of the parts of the washing machine, etc. Right? So something is missing, right? When we think about it, right? Why aren't we find the solution to our question? There must be something is missing. It is important to identify what those somethings are, right? So what are actually missing? So that is, of course, since the idea of whether we are able to live forever, right? So people have been trying to think about that. So we have this experience, right? So let me just try to put that experience up in a model or in a chart. You start with a broken appliance, and then if you want to repair that appliance, that could be a washing machine, a radio, a television, a camera, etc. So the first thing, if we were to try to repair the appliance, then we must need to know to understand why, right? How does it work? How does the radio work? How does the camera work? How does each part of the appliance will work? All right? And then when we understand how things work, we will be able to find a cause of the problem, right? At least the chance of finding out the cause of the problem will very much increase once we understand how that appliance would work. Once we find out the cause, then there's a chance that we will be able to work out the problem. I'm not saying that this will come up automatically. Well, very often we know the cause, but we still don't have the solution. Because again, one thing is lacking, the approach. We know why, but do we know how? When we know how, it doesn't follow that we must know how. There's the approach that is lacking. Now, so that is the simple model, right? From the broken appliance and finally, right, being able to solve the problem. So can we use this model, try to understand, right, why our ancient ancestors have not been able to find a solution, find a way to live forever? Well, I think there are, from this, what will transpire from this model? It appears that from the experience of making a repair to a household appliance, three things we must have, and that is the working principle. We need to, on the basis of the working principle, we need to identify the key question. Simply asking whether humans can live forever would be useless. You must now try to think deeper. And that is what actually is the key question that we are being faced with. And the approach, we have the question now, how to find the answer for that question, the approach, how to do that. So again, we need to recall a little bit of things out. And that is the original question that was asked by our ancient ancestor, right? Is how to live eternally? What does it take to live eternally? Alternative, right? So there are many ways to phrase the same question, but every time we come up with a different version of the question, right? We might be able to get some insight from the new version. So with that, we can use our experience of repairing a bicycle, for example, to ask the same question again. What is the principle, the working principle of life, right? Why are we able to stand here? Why am I able to stand here and talking, right? Why are we, right? How does the human body function? What is the working principle of life? What is the key question? The key, that is important. If we can't identify the key or critical question, we won't be able to solve our problem. Right? If we ask, why can't we last forever? Perhaps we might ask, what actually is preventing us, right, to live forever? What is preventing us to have a so-called an eternal life? Or maybe what is preventing us to be freed from diseases? Right? And then if you know the answer to this question, then the next thing that we need to ask is, what is the approach, right? If we know how the human body works, right? If you know what is actually preventing the human body to function forever, then perhaps we will be a little bit close to the approach. So at this point, there's a very important thing about how our mind works, and that is asking questions, right? If we aren't able to ask questions, we will not able to solve problems. So I've tried to to show that there's a peculiar nature of questions. In that, did you discover that whenever we have a question, that question is usually a result of other hidden questions, right? A question within a question. It's always like this, right? That is the properties of questioning. It may not be easy to find those hidden questions, and that will really rely on our so-called analytical power. Any question can give rise to new questions, and that is important. See, solving that very simple questions, can we live forever, is actually not one single question, but is actually a nest of questions in disguise. The point is, are we able to unfold the nest and look at every question carefully? Any question is composed of other questions, right? So of course, right, we cannot unfold any one single question, right, instantly. In the case of the so-called biomedical science, it took thousands of years for us to gradually to unfold that original questions. So when I ask what is the working principle of life, right? So he is telling us that I'm asking a nest of questions. For example, when I say what the working principle of life, we need to know what are the substances, the so-called the building blocks of life, right? So any students who have attended elementary lectures in biochemistry, right? We know what is meant by the building blocks of life: amino acids, carbohydrates, fatty acids, vitamins, etc. Right? What are the substances? What are the substances that are essential for the building of life? These substances must, of course, be used to build up some sort of structures. What is meant by that? Our bones, our muscle, nerves, eyes, blood, a lot of things, everything in the body, structures, that is important, right? And then the functions. What is the function of our heart? Do you think that our heart is only responsible for pumping blood? Not really. What is the function of the liver? What is the function of the intestine? What is the function of the kidney? Right? Again, of course, the kidney is very complicated, right? And it has multiple functions, and so a lot of other organs within our body. Structures, functions, substances, and then the driving force. The substances, if you continue to trace back, you find that the substances that are responsible for building up the so-called the building blocks of life are exactly the same substances, right, that are responsible for all the things that you see here, the carpets, the materials that build the chairs that you're now sitting. The same substances. But what? But why that in the human body or in any other life forms that the carbon atoms, for example, the hydrogens, the oxygen, the nitrogen, will come together in a specific manner to start assembling what we call the building blocks of life, the driving force. And can you suggest, and of course, information, right, with which the driving force will follow to put all this together into structures that will give us the functions, function of the liver, function of the kidney, function of the heart, function of the brain, right? So you see, that is what I meant by any question is actually a nest of questions, which I've shown here. A network, they are interrelated. If you continue to ask, this is not the end. You can still, this one single question is actually a nest of questions in it. It is not one single question. So each of the spheres, each of the notes that you can see here, right, is actually itself is a nest of questions. So whatever question that we ask, we are actually asking an unlimited size of interconnected questions. Now, that is how biomedical science have developed over the past 1,000 years. So we begin with that apparently very simple and naive question. Can we live forever? Can human body last forever? Without knowing that it is a nest of questions. But then over the years, it has generated into, or it has given rise to many other networks of questions, right? And what are these networks? Just to name a few, right? For example, this represents the various so-called disciplines, scientific disciplines that every single student of life science you need to study. Biochemistry, cell biology, right, and immunology, right, a lot of the stuff, and which is shown in the next slide here, major examples of those networks, And that is when the biomedical science is in its sort of infant stage. So we have, first of all, we have biochemistry, molecular genetics. These are all building blocks of biomedical sciences: cell biology, physiology, immunology, right, developmental biology. Biochemistry is perhaps the oldest of all these fundamental disciplines. Biochemistry talks about the substances that are responsible for building up life, right? The molecules, so-called biomolecules, right? Familiar terms maybe enzymes, right? How enzymes work. DNA, right? Deoxyribonucleic acids, RNA, various proteins, various carbohydrate structures, starch, for example, molecules at the molecular level, right? And then molecular genetics. It begins, of course, with genetics when the concept of a gene was developed on the basis of studies of how traits in certain types of plants are being passed on from one generation to the next. Traits, characteristics, for example, the color of the flowers, how the colors of the flowers could be passed on from one generation to the next. Right? Traits, characteristics, features. So that, right, that's the beginning. So that is being explained by this hypothetical concept known as a gene. At the very beginning, a gene is just a concept, right? We don't know what a gene is. And then, of course, later on we discovered that a gene, right, the physical interpretation would be sort of a particular sequence of nucleotides in a nucleic acid. So now, and then with that, this discipline, molecular genetics, have started to develop. Cell biology. Why are this not enough for us to understand life? It is because it is very peculiar, very interesting is that being able to understand how a particular type of so-called biomolecules would function. For example, people have spent a long time in understanding how enzymes would work. But the understanding of enzymes as such in isolation is no representation how life would work, right? Enzymes must need to come together, right, in a particular functional assembly in order to exhibit certain characteristics that is responsible for life. Of course, it doesn't stop there. Enzymes and other molecules. And then cell biology is the study of a cell, right? A cell, right, we can only, right, look at the characteristics of a cell if we are only dealing with a cell. We cannot understand a cell in terms of its molecules. Because when molecules come together, it starts to exhibit special characteristics that will only appear when they are in the form of an assembly. Physiology, the studies of organs. It is, again, not enough to study only cells in the isolated state, because when cells come together, they begin to exhibit properties, right, or characteristics that cannot be seen in a single isolated cell. Right? Physiology, immunology. Right? It talks about how, right, various organisms, life forms, the human body, for example, will be able to interact with the surrounding environment in a safe way, defending so-called pathogens. Developmental biology, how a fertilized egg would finally become a fetus. So these are the building blocks of biomedical science. Now, with that, we are now reinvigorated. We now have something new for us to come back to the first question that was asked by our ancestor. All right. So now we are able to get a more complete picture of the so-called working principle of life, right? We are at the same time getting a more holistic, right? Remember what I've said, right? A cell has properties that can only be seen when we're dealing with an intact cell, not as single isolated molecules, right? So we're now able to rebuild, right? Trying to look at life in a much more detailed manner. With that, as I've said, just like going back to the example of repairing a bicycle, we now have an idea of the working principle. So we are now qualified, right, for the first time to try to ask, why do we have diseases? And then knowing the unknowns. There are times, a lot of the times, that we are pretty sure that, okay, yes, this is something that I can't do. But have we ever asked ourselves, what is it, why? What's the reason that we cannot do that? What is it that we don't know, right? We know that there are a lot of things we don't know, but we ask ourselves, what are those, right? Knowing the unknowns. Now, with those fundamental disciplines like biochemistry, cell biology, molecular genetics, we are able to start to uncover, to pick out, to discover what actually are the unknowns concerning diseases, right? So now, biomedical science have again moved one step forward. Before that, I would prefer to call it biological science rather than biomedical science, because, right, we are not yet able to intervene with disease process. But starting at this point, we are doing that. We are starting to ponder to see how we were able to intervene with disease processes once we understand why and how diseases occur. Intervention. Of course, if we want to do that, we need more questions. We need to ask more questions. We start off with this core discipline, right? The question of our ancient ancestors give rise to all these core disciplines: biochemistry, cell biology, molecular genetics, etc. That is not yet enough for us to intervene diseases. We need something else. We need something more. Knowing the unknowns, because there are a lot of unknowns that we know, that we need to know. For example, synthetic biology. We have been talking about a gene. We know that gene is a particular sequence of nucleotides. But does it mean that any sequence of nucleotides is a gene? No. We still don't know exactly how we could write that sequence. And that is what synthetic biology is doing. Can you create a new gene? That's the point. You just can't randomly put up a sequence and then, this is a gene. No. But do we know how to write a meaningful sequence? It's just like writing an essay, right? Putting various words together is not an essay, right? You need to know what word to use. System biology, right? How to look at the various systems, how the liver interacts with the heart, for example, and then even at the level of a cell, right? For example, in the case of metabolism, we need to know how all the enzymes within a cell could form together to make what we call a metabolic network in order, right, to give the results that we want, right? Why is it that after drinking a lot of sugar, that our blood sugar level will remain more or less the same for a normal person. I'm not saying diabetes, right? Why? How? That involves the interaction of every single cell in our body, system biology, working as a system, right? It's not in isolation. Bioinformatics, that is big data. In order to do this, we need to use big data approach. That's why we need to use bioinformatics. Stem cell biology, right? We know that there are cells within our body that remains the power of giving rise to all other cells in our body. Right? That is very important because it leads us to a thing called regenerative medicine. How to regenerate a liver, how to regenerate a ear, how to regenerate an eye, right? Precision medicine, bullet drugs. I'm not sure whether, well, this is already an old term, bullet drugs, right? For example, in the treatment of cancers, it is very important that we must be able to just kill the cancer cells and not other cells. Precision medicine. So, as you can see, biomedical science has come a long way. It starts with very naive and simple questions, but over decades or over centuries or thousands of years, we've made a lot of successes, right? And all those that I've talked about, all those disciplines, would enable us to do one very important thing, and that is an atlas of the human body. An atlas, a map. And that is not a simple map because it is going to be a map that will incorporate a lot of the characteristics of life. Just name a few, for example, cell-cell interactions, cell-environmental interactions, and the element of time because, right, starting at the time of conception, right, already, right, we need to know how that changes will take place over the entire lifespan of the human body. That is going to be a very complicated atlas. It is multi-dimensional. We still haven't completed it yet. We need that atlas in order for us to devise the approach to treat diseases and maybe hopefully finally one day we'll be to achieve what our ancient ancestors would like to achieve. Of course, there are a lot of things that we haven't done now. So now, which is the difficult bit, right? It's easy to come up with those network of questions about medical science. But does it mean that biomedical science will then automatically benefit the human society? Not quite, right? Think about the invention of the atomic bomb, right? And then it's the same argument. Biomedical science is neutral, right? It can do good to the human society. It can also do the opposite to human society. How are we going to make sure that it will do good to the human society, right? Living forever. Do you think that being able to live forever is a good thing, right? So what if everybody is going to live forever? What will happen to the world population? For example, a lot of things, insurance, right? That's our immediate concern, right? Our retirement schemes, right? Cost of living, that's the immediate concern. That's society, the impact on the society. It is going to transform us in the coming centuries, but in what direction? That's the question. So coming back to the purpose of the talk today, what is biomedical science? I would say that biomedical science is an enormous network of questions that is related to life, right? And then everybody, if you are going to engage yourself with biomedical science, you're actually taking part in asking those questions and maybe answering those questions. And then, I mean, let's be realistic, right? And for example, maybe the aim is to see whether we can be free from diseases and then maybe living healthily, aging healthily. And maybe finally, we may be able to achieve immortality. Who knows? Do we really want that? That's the point. And it is a science that is supported by all disciplines of science, and that's including mathematics. So so biomedical science have come a long way, right? Since the time of our ancient ancestors, right? It has developed now to really a type of science known as biomedical science. We don't know whether or how beneficial it would be on us. It seems to be enormous, but only depends on how we are going to make use of it. So over the generations, right? So people come and people go, right? So we need new blood, and therefore we count on you all to continue to make biomedical science beneficial to mankind. So I thank you for your attention. So if you have any questions, and if I was able to answer, I would be happy to respond.
Dr. Wong, I have two children. One is 16, one is 17. They are about to want to study medicine, but they cannot be admitted. If they want to save lives, what is your advice? I want to send them to study public health, biological science, or pathology, or biochemistry, to help them to understand more if later on they want to study medicine as a second degree or second undergraduate. So what is your advice to work in a drugs company?
I think for your children, you need to ask them to think what actually are their strengths, right? So when you are talking about they want to save lives, so there are many ways to save lives. Many ways, right? You don't have to be a doctor in order to save lives.
Fireman,
right?
policeman.
Right? So you need to ask what are their strengths, right? What sort of things that they really would like to do. They could be a scientist. Very meaningful to me, right? Of course, you will not be earning a lot, right? That's for sure, right? But then the work that they do as a scientist will be profound if they had got that sort of so-called aptitude, right? If they that sort of inclination, right, to do that. They may not have, right? So you really need to ask them, right? You cannot force them to do this or that, right? It really depends on their own inner driving force, interest, etc. It's a good thing that they want to save lives. Yes, yeah. But then, are they interested in biology? If they said, oh no, sorry, I'm not interested in biology, then full stop. There are many ways, right?
But they are not scared of blood or dead body. So after 3 years pandemic, the COVID-19, so we think the infectious disease is more important. So do you think that they should go back to the basic to study biological science or biochemistry, or as the pharmacies to research on this
Yes.
medicine to save lives?
Yes, if they are interested in research, say for example, because of the experience with COVID, and then suddenly this mRNA vaccine is so appears to be so useful, immunology, right? So even if he or she is interested in physics, they will be able to make a contribution in the development of all this mRNA medicine. These days, right? anything is multidisciplinary. We cannot just rely on biology or biochemistry to make discoveries. A lot of physicists now take part in the research, in life research, physicists, and of course chemists. Math is now is getting very important, math, because of big data. So there's a lot of opportunities, right, for your children to achieve that grand aim of saving lives.
Thank you. Thank you.
We have this, we can clone or duplicate a lamp 20-something years ago. And also, I think it should be a couple of years ago, I heard the news that we can censor the coding of the DNA, take away some disease, or you can make a superhuman. So, but suddenly everything stopped it. So what is the ethical discussion or impact on this, according to your point of view? Should we continue to do the censor of our DNA or coding, or any ethical thing that we have to think of?
Yeah, because once we are able to change the basic characteristics like your intelligence or your resistance to disease, the impact will be enormous because it's going to change a lot of the traditional values, right, that are responsible for binding us together, right, that has been able to make us to live relatively happily, right, for centuries. So supposing that suddenly you've got a superhuman, right, how about the others? They will be outcompeted. So what are we going to do? Superhuman or what? So that's a lot of the countries are now thinking on these issues, right? Drafting laws to to regulate, right? All this, the application of all these scientific discoveries. I think you're talking about CRISPR, and that is really a very promising approach to re-edit our genome, right? To re-edit our genome. Of course, we are still in the stage of finding out how, right? Although there are lots of so-called proof of principle experiments that have been reported and done. But in the long run, after editing a particular gene in the genome, what is the consequence on the long-term health and development of that individual? We don't know. Because even if you alter one nucleotide out of the entire genome, you're actually altering the entire genome, right? So in Chinese, it's 牽一髮而動全身, right? So that is, I'm not sure whether I hope that you understand what I'm talking about.
Okay, so thank you very much, Dr. Wong.
Thank you.
So if no further questions, then I think that's the end of our talk today. So thank you very much for all the audience who came face-to-face in our open space events, and also to the audience on YouTube Live. Also, please remember to join us for our afternoon session at 3:45 p.m. We will discuss more about the Hong Kong U Space biomedical science programs. So if you have any questions related to those programs, you can feel free to join us there. Thank you.